Good evening, everybody. My name is Bill Kanzinger, and I do the technology instruction here at Cape Fear Academy. First of all, I'd like to apologize for not being here tonight. My middle daughter, Megan, is going up to college, and I'm in Baltimore right now dropping her off. Very much like to be here with you tonight, but I guess this will have to do for right now. First, I'd like to tell you a little bit about myself. I'm married. My wife, Cheryl, works here at Cape Fear Academy. She's the assistant to the technical director and the assistant to the drama director, as well as the costumer for the middle school and upper school shows. My daughter Ellen is a junior now at Washington and Lee. She graduated from Cape Fear Academy in 2014. My daughter Megan, as I said, is going to be a freshman at Loyola of Maryland. She's a graduate of Cape Fear Academy, class of 2016. My son Eric is currently in 11th grade here at Cape Fear Academy. As for myself, this is now my 14th year at Cape Fear Academy, my 25th year as a teacher. I graduated from the College of Worcester in 1992, got my master's degree from Kent State University in 1997, and here I am now. So among the different responsibilities that I have here at Cape Fear Academy, I am the Fine Arts Chair. In addition to that, I teach Future Minds, which is sort of a STEM-based class to the lower school, grades 1 through 5. Here in the middle school, not only do I teach 3D design and graphic design, but I also have Game Design 6 and Game Design 7 and 8. I also teach a robotics class at the high school, a class called Intro to Technology and Design, and a Design and Presentations class, all at the high school level. Alright, so let's talk about 3D design. What is it exactly that your students are going to be doing while they come and visit me for 3D design? Well, first of all, they're going to be introduced to a number of different programs that are going to help them sort of develop their projects. So we start out with a program called SketchUp. SketchUp is made originally by Google, and it was built for Google Earth so that people could make 3D buildings and place them into Google Earth. And since then, it's really kind of developed into an architectural program. The great thing about SketchUp is it's very easy to learn, it's very easy to pick up, and the students will be able to start going in right away and building up these 3D objects, and it's a lot of fun to sort of do that. What you'll start to find, though, is as you get more and more skilled, there are some limitations to SketchUp. And so when we start hitting those limitations, we'll move on to a program called 1-2-3D Design. 1-2-3D Design is made by the same company, Autodesk, that does AutoCAD, as well as some other really advanced 3D rendering programs. 1-2-3D Design was really built for 3D modeling and 3D printing. We have found that when we use SketchUp, every now and then when we go into the 3D printer, SketchUp doesn't always translate very well, and so we might be missing faces or vertices, and the project just fails when we go to print it. 1-2-3D Design is much more consistent. We haven't really had those kinds of issues. When you build something in 1-2-3D Design and then take it over to the 3D printer, it prints pretty much every single time the way that you laid it out. 1-2-3D Design has a little bit more of a learning curve. It takes us a little bit longer to get comfortable with it, but once students get comfortable with 1-2-3D Design, they typically don't want to go back to SketchUp. Now, once we finish with 1-2-3D Design, we move on to a program called Blender. And Blender is just going to blow your students' mind when they first see it. It can be very overwhelming to begin with. Blender is something that if you wanted to make a movie similar to what Pixar does, you could do that. You could make photorealistic images. You could then animate them. You have cameras and light sources which you can animate. So not only could I get a block, for example, to roll across the screen, I could have the camera follow that block in the opposite direction while the light source is kind of arcing overhead. Just like with 1-2-3D Design and SketchUp, I can export my models as an STL file and then print those out. So that's the other thing that we sort of need to talk about when we talk about 3D printing is there's some things that our students need to keep in mind when they're doing that. For one thing, our printers are extrusion-based printers, which means that you take some plastic, you feed it through what's called a Bowden tube, that goes into the extruder. The extruder heats the plastic up to about 215 degrees Celsius and turns it into kind of a thick liquid, which it then squirts out. It's very similar to squeezing a toothpaste out of a toothpaste tube. That gets squirted out onto the base plate. So layer 1 goes on the base plate, then the base plate lowers a little bit, and the next layer gets squirted out, and so you progressively sort of build it higher and higher, and there you have your print. The problem, of course, is if I'm using a sort of a liquid to make this print, if I have an overhang, that liquid's just going to drop right down. So we have to talk about what we can do about that. And sometimes it's as easy as, let's say I'm printing a table. I've got the legs coming up, and then I've got the tabletop here, but that underside of the tabletop is just going to droop down if I try to print it. If we simply reverse the table, flip it on its upside down, we print the top of the table first and the legs coming up, that would be one way that we can counteract that. But there's other things that we can do as well, including building supports and building things at an angle. When we build the supports, we would just kind of break those off. So there's different design principles that we will talk about when we talk about just building something for 3D versus actually then trying to print that. And we will have an opportunity to print some of the projects that your students make. Now, I'll give you this warning. 3D printing is very, very slow. A typical print, maybe only about that big, is going to take about 3 to 4 hours to print. And I've had students last year who had prints that lasted over 3 days, where I would literally start the print at 8 o'clock in the morning, leave the school, overnight, come back, and it's still not even halfway done. Come in the next day, it's still working, and come in the third day, and maybe by that afternoon, it's finally done. So it's not exactly something that we can just say, okay, let's everybody give me your print, we'll crank it out by the end of the class, and you'll get it to take it home. So not only that, but I also have high school and lower school classes that use the 3D printers, so that we have to just sort of take our time and make sure that everybody gets a fair turn. We do have 3 3D printers on campus. We have a MakerBot, we have a Solodoodle, and we have an Ultimaker. Now, the Solodoodle is a little bit old, a little long in the tooth. It had an accident a few years back. It doesn't always communicate well with the computer. So sometimes we can get that to work, sometimes we can't. MakerBot is an outstanding printer. It's got a base plate of about 5 inches by 5 inches, so we can do some nice small prints. Doesn't take quite as long. It's been very reliable for us, an outstanding printer. The Ultimaker is our newest printer. We just got that a year ago. It can do about a 9-inch by 9-inch build. The nice thing about the Ultimaker is I can also set the resolution. So the MakerBot I can set at about 200 microns, which is like 0.2 of a millimeter. The Ultimaker I can go down to 20 microns, which gives me some really nice detailed prints. Downside, takes even longer. So we have to kind of balance what kind of settings we want to do, speed versus just how well and how refined that print comes out. So we find that balance and we do okay. So over the course of the semester, your students will be working with these 3 programs. I will give them different things that I want them to do. Each project that they do will have sort of a specific goal in mind to help them work on a skill that I think that they will need as they continue to evolve as 3D artists. And finally, at the end of the semester, if we're able to get through everything that I need to get through, they'll have a chance to do an independent project. And so they can choose any of those 3 programs that they want, and if they've got some kind of interest that they want to explore further, away they go and they can have at it. So look forward to that, seeing the creativity of the students. My door is always open. Please feel free at any time if you want to come in, even while I'm teaching, to come in and observe, see what we're doing. If you want to take the class yourself, come on in. We'll show you how to do some stuff. That would be great. Email me if you have any problems, any questions, any worries, any concerns, any joys. If anything, any kind of feedback you provide me was only going to make the curriculum that much stronger. So never feel hesitant about reaching out to me and asking questions or sharing things, giving me feedback about what's going on. Again, I apologize for not being here tonight. Really wish I could see you all. But like I said, please feel free to stop in anytime, and I'll be happy to talk with you about how your child's doing or about what we do with technology here in Cape Fear Academy. Have a great evening. We'll see you all later.